Trigonometry, Chapter 6, Test Review. Got some verifying, a solve, and an evaluation. Remember that you need to know the identities, you need to know the reciprocal identities, the quotient identities, the Pythagorean identities, the angle sums and differences, and the double angle identities for our test tomorrow. There will be no notes used. So tan over 1 plus secant plus 1 plus secant over tan equals 2 cosecant. So anytime that we have fractions, let's get a common denominator. So our common denominator will be tan alpha times 1 plus secant alpha. So think about what we're actually missing. This first fraction is missing 1 power of tangent, so we multiply by 1 power of tangent. That makes tangent alpha times tangent alpha, which is tangent squared alpha. To the other side, we're missing, 1 plus secant alpha. 1 plus secant alpha. So 1 plus secant times 1 plus secant is going to give us 1 plus 2 secant alpha plus secant squared alpha. When we square that binomial, this is what we get. So just don't even touch that right-hand side. It's too easy. Just let it ride. We'll even just bring it down right here. Let's continue to work on this left-hand side. So here's the next thing I see. I see a Pythagorean identity, and there it is, right there. Tan squared plus 1 is actually equal to secant squared. So we've got secant squared alpha plus 2 secant alpha plus another secant squared alpha over tan alpha times 1 plus secant alpha. Of course, secant squared plus secant squared is 2 secant squared. So I probably could have written that, but wanting to show every possible step here. So now we are at 2 secant squared alpha plus 2 secant alpha over tan alpha times 1 plus secant alpha. Next thing we can do here is factor. Look at that numerator and see that common denominator, see that common factor of secant alpha. So let's take it out and get down to some paper. So here we go. So take out that common factor. That common factor is 2 secant alpha. So what's going to remain? We're going to have secant alpha remaining because secant squared divided by secant leaves secant, plus 2 secant alpha divided by 2 secant alpha is 1. And check it out, boys and girls, something is about to cancel. So secant alpha plus 1 on the top, 1 plus secant alpha on the bottom, cancel. And I'll move to the right here. We are left with 2 secant over tangent. So think about what 2 secant over tangent actually means. That would be 2, let's go 2 over cosine. So just taking the reciprocal of that secant theta, secant alpha on the top, over tangent, which is sine alpha over cosine alpha. Now we can cancel those denominators, and we're left with 2 over sine, and of course 2 over sine is the same thing as 2 cosecant alpha. So there we go. That took us all the way back to the beginning to what we wanted, 2 cosecant alpha. That is a solid problem right there, mathematicians. Let's look at the next one. It's another verify, and yes, I have chosen some more complex verifying problems so that you'll be fully prepared. So here we've got secant x plus tangent x quantity squared equals 1 plus sine over 1 minus sine. I'm not even going to touch this right-hand side. I'm going to work on the left-hand side first. And what do we have here? What we've got is, and I think I'll actually even go to sine and cosine first here. We've got secant, which is 1 over cosine, plus tangent, which is sine x over cosine. And still working inside these parentheses, we've got a common denominator here, which is cosine. So we've got 1 plus sine x over cosine x, quantity squared. When we square this quantity, we end up with 1 plus 2 sine x plus sine squared x over cosine squared x. And honestly, we probably shouldn't even have squared it because I now see what needs to be done. Actually, we will leave it there. Let's work on the right-hand side because I think it would be more easy to get the right-hand side to become the left-hand side at this point. So if we see a cosine squared on the bottom, what could we multiply to 1 minus sine x to get us to cosine squared? I think if we multiply by that conjugate, which is 1 plus sine x, 1 plus sine x, so 1 plus sine x times 1 plus sine x is exactly the same thing we've got right there. So that's a good thing. And then on the bottom, 1 minus sine times 1 plus sine is 1 minus sine squared x, which of course is cosine squared. So that is one way to do that problem. Of course, there are many, many others. So verified. We made the right-hand side and the left-hand side become exactly the same thing. Next, we've got a solve. And I specifically picked out this problem again to remind everybody that if you see an opportunity not to divide away a greatest common factor, but to bring out that greatest common factor, while of course we're set equal to 0, this is what we want to do. So tan x is coming out. That leaves 4 sine squared x minus 1. 1 factor, 2 factors, set equal to 0. So tan x equals 0. And 4 sine squared x minus 1 equals 0. So if 4 sine squared x minus 1 equals 0, then sine squared x equals 1/4, which we will take the square root of. And just as a reminder, when we are solving and we take the square root of both sides of an equation, we don't just get one answer, we will get 2. The square root of 1/4 is plus or minus 1/2. So we're about to get several answers here. First of all, where does the tangent equal 0? Of course, the tangent is equal to y over x. So the tangent is going to be 0 at 0 and also at pi. The coordinates at 0 are 1, 0, and the coordinates at pi are -1, 0. So specific solutions first are going to be 0 and pi. And the general solution, recall, these two solutions are pi units apart. So we can just do this with one general solution of pi times n. So specific and general. On the other side, if we have sine x equals 1/2, the sine is going to equal +1/2 or -1/2 everywhere we have a 30-degree reference angle. So that's going to be at pi over 6, also going to be at 5 pi over 6. They're both positive there. Then they're negative on the bottom, 7 pi over 6 and 11 pi over 6. So more specific solutions, all 4 of those. So that's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And then since these are 2 opposing poles, we only need 2 general equations here. So the first one will be pi over 6 plus pi times n, and also 5 pi over 6 plus pi times n. So 1, 2, 3, 4, 5, 6. 6 specific solutions and 1, 2, 3 general solutions. One more time, if you see an opportunity to take out a GCF, in this case it's tan, do so. Set it equal to 0, both factors, and solve. Last up, went over this in class. The key to these problems, two things here. Being able to correctly draw the diagrams, and yes, the diagrams are mandatory in order to get full credit. Secondly, applying the formulas. In this case, a sum, in this case, a double angle. So once again, you do have to know the angle sums and differences formulas for sines and cosines. And you also have to know the double angle for sine and cosine. I'm not going to give you a tangent on the test. So first thing, let's draw the pictures. So I'll draw the pictures right over here. Alpha. Secant alpha equals -4. So think about this, ladies and gentlemen. If secant alpha equals -4, by the reciprocal function, that must mean that the cosine of alpha is -1/4. And we are looking at alpha, which is going to be in quadrant 2, which is between pi over 2 and pi. So here is alpha. Once again, be reminded, I am looking specifically at your diagrams. They will be assigned points and they are mandatory. The cosine here is adjacent over hypotenuse. Remember, the hypotenuse is always positive and the altitude is always dropped to the x-axis. So let's find that missing side. 4 squared is 16. -1 squared is 1. 16 minus 1 leaves our missing side as root 15. It is positive because this altitude is being dropped down. So there's alpha, everything we wanted to know about alpha. Tan B. Tan beta is 2/3 and tangent is positive in quadrant 3, and that's where beta lives. So there's beta, and the tangent, which is opposite over adjacent. Think about it, they're both negative because we're in quadrant 3. We're after that hypotenuse. 3 squared is 9, 2 squared is 4, 9 plus 4 is 13. Root 13 is our hypotenuse. So we are going to have to rationalize something here. First, let's go after the sine of alpha plus beta. I'm going to write that formula for you. Sine alpha, cosine beta, plus cosine alpha and sine beta. So if you draw the diagrams correctly and you know this formula, then all you got to do are make the substitutions. So sine of alpha. Sine of alpha is root 15 over 4. Cosine of beta, -3 over root 13. Next, cosine of alpha, -1 over 4. Sine of beta, -2 over root 13. Now we just need to simplify. We've got a common denominator of 4 root 13, which we're going to rationalize in just a moment. To the top, root 15 times -3 is -3 root 15. -1 times -2 is +2. So we're going to rationalize this fraction by multiplying by root 13. That's all that's necessary. It's just a single monomial expression. So let's simplify. We do need to distribute the numerator. So -3 root 15 times root 13. So what is 13 times 15? So 13 times 15 is 195. And because it's 13 times 15, there are no perfect square factors, so it's just going to stay. So -3 root 195 plus 2 root 13 over 4 times 13, which is 52. So that actually is simplified. Let's go for the cosine of the double angle. So the cosine of the double angle has 3 options. Pick your poison. I'm just going for the first one, which is cosine squared alpha minus sine squared alpha. From here, we just need to substitute in the values. Back to the diagrams, the cosine of alpha, 1/4, negative 1/4. The cosine, or excuse me, the sine of alpha, because remember this is 2 alpha, so everything about alpha right here. The sine of 2 alpha. The sine of 2 alpha, opposite over hypotenuse, so that is root 15 over 4. Both of these are getting squared, so we're following order of operations. So that is going to be 1 over 16 minus 15 over 16, and that is negative 14 over 16, which we can simplify to simply negative 7/8. So once again, when you're given all this information, remember the secant, the cosine, the tangent, cotangent, sine, cosecant, all of those represent a triangle. So when you're given information like this, the first thing you need to do is draw a diagram. Once again, I will remind you that you do get points for drawing the diagrams, so do not neglect that. So solving, verifying, biggest thing you have to know for tomorrow is you have to know the identities.